In this part of the tutorial, I will go over the scripts that we wrote here at the University of Chicago to assist with the trigger validation shifts. Currently, the code is hosted on Google Code, but eventually it may move to CERN. So here is the URL on Google Code where you should navigate. Here is the link that is the command that you can use to check out the code on any Linux machine. If this is the first time that you do the shifts, you should email one of the developers, for example myself, and this is my address here, kapli@gmail.com, so I can add you to the list of committers for this project, because you need to update the scripts with all the new bugs that you identify in the course of your shift. A couple of comments about this page. Here on the left we have a list of useful links, some of which you've seen in the previous part of the tutorial. So this is the link to the Nikos page that lists all of the nightlies that need to be reported. Here is the list to the Savannah bug tracker, and this is the list to the master trigger validation wiki that you should also read. We also have some documentation that you can access by clicking the usage instructions link. This is fairly detailed, and this will largely mirror what I will tell you in the next 5 minutes, but this has more detail, so you should definitely read it. So, one note I should make at this point is that you need Python 2.6 or above, and that's pretty much the only dependency to run our scripts. You can check whether you have the right version of Python by running this command, python --version. And here I do have Python 2.6 or above. Python 2.7 should also work. Python 3.0, though, will most likely not work, so you'll need to find another machine. You can always run on LX Plus, of course, if you don't have your own machine with Python 2.6. Anyway, if you use this svn checkout command, which I've done already, you'll be presented with a list of files. The main script that runs the shift is called run.py, and it has the following syntax. You say run.py space, then you give the release number. Recall that's that number from 0 to 6 that tells you which day of week you're running the shift for. Since it's Saturday now, we are going to run this for 6. And then there is another optional argument that selects a list of nightlies that this invocation of run.py will analyze. If you leave this second argument empty, it will run over all nightlies that you need to report in the course of your shift. But usually that's not what you do. Usually you run nightlies as they finish on the CERN machines, and some of them finish earlier. And so we roughly split them into 1, 2, and 3. So let's run the first part. So this is the whole command, and I'm gonna say enter. The script will go through all of the logs for all of the nightlies that are associated with part 1. So right now it's working on the P1 HLT nightly, which consists of 2 subprojects, trig P1 test and trigger test. In general, it may take between 1 and 3 minutes per nightly. So let's wait and let's see how it goes. Okay, it finished P1 HLT, and now it's working on Atlas CAF HLT. Those 2 nightlies, by the way, have been chosen to be under part 1 for a reason. They finish first on the CERN side, and they're the most important ones. So as soon as they finish, you should run this command and send the report out without waiting for the other nightlies to finish. So let's see, this one seems to be taking a little bit longer, but that's fine, we have time. I think this one has another ATN project, basically another series of tests, but we'll see in a second. Uh, well, while it's running, maybe we should talk about something else fairly quickly. Uh, if you are going to take a lot of shifts, I highly recommend that you add yourself to the Atlas Trigger group on the Savannah. In order to do this, go to Savannah, make sure you're logged in, and then go to My Groups. You can see I'm already a member of this group, but if you aren't, you can go into this dialog box and just search for Atlas Trig, and then there will be a link to join. The reason you should join is you will gain the right to modify the bugs, and that's a very useful feature. So you see here I clicked arbitrarily one of the bugs, and if I determine that this bug no longer occurs and should be closed, I can do this here. Okay, so let's see if our shift finished. Okay, it finished. So what you can see here in the terminal is a brief summary of what the script identified. There's quite a number of bugs that it found, and they're listed here. The actual output of the script is contained in a file called index2.html. If you're running on your laptop, you can just open it with your favorite browser, or you could SCP it to your public HTML area in one of the machines you have access to. So I've already done this, and this is the HTML file that the script run.py produced. There is a bunch of boilerplate stuff on top that's basically here every time, and in the next part of the tutorial we're going to go over the structure of this report.